Alright, this is day 7. We're going to be talking about exponential growth and decay on this lesson. These are all going to be word problems. Now, we're going to still be using y equals a times b to the x, and a is still going to be initial population. Y is going to be how much that population is. B is going to be your growth or decay factor, and x is going to be the amount of time usually. Now, let's go ahead and take a look at this first problem. On this one, $460 is my initial population for the money back in 1985, and that's how much it initially costs whenever they started this function. Next, I'm going to figure out what B is, and to do that, I'm going to take 1 and I'm going to actually add 8.1% to it, and here's what that looks like. Now, 1, because if I multiply something by 1, it's not changing, represents a 0% change. So if something's not changing, it would be a base of 1. In that case, we wouldn't be using these kinds of functions. Now, in this case, I add 8.1% to it, which would be 0.081. 8.1 divided by 100 is this one. And the reason why I'm adding is because it's going up as time goes on. Now, that ends up being 1.081 for my B value. And that is my function. As an extra note, you should mention what your variables represent. So x is the number of years since 1985, and y is the cost per day. And that is my final answer. I've modeled it as a function. That's all I was supposed to do here. On this problem, we're doing money again for our population. So my initial amount on this problem is $1,500. Now I'm going to figure out what B is by doing 1 plus 0.065. Again, 1 because that's 0% change, and then plus because we're gaining 6.5% annually on this. That will be 1.065 that I'm using for the value of B. And it will be to the x power. Now x is actually going to be 18 on this specific problem because that's what they told us over here. And so I'm just got to type this in the calculator and I get $4,659.98 as my final answer. All I did was type this in on the calculator as you see it. If you're using a scientific calculator at home, just type in 1.065, raise it to the 18th power, and then multiply that answer by 1,500 to get your correct answer. Alright, this is a half-life problem, so the substance we're dealing with here is iodine 131. Every 8 days, half of it changes into something else, half of it remains. So half of it's gone every 8 days is how this works. Now, this is going to be our first exponential decay problem. So here's how it works. Y equals, the initial amount is 12 millicuries. That's the measurement that they're giving you as your initial population. For B, I'm going to use 0.5. Now, is it always going to be 0.5 on half-life? Yes, because half of it's gone. 1 minus 0.5 will leave you with 0.5. So half-life always has a base of 1/2. Next is my time, and that's the bit of a tricky part on this. It's actually going to be a 2, and that is coming from the fact of the number of cycles that this stuff has gone through. Because its half-life is 8 days, since 16 days has passed, it's gone through 2 cycles. Now I can finish typing that problem into my calculator, and I'll get 3 millicuries. By the way, that would simply just be 12 times half, which would be 6, and then times half again would be 3 millicuries. You actually didn't have to make a function on this problem to get it done, but isn't it pretty? Aren't you glad you did it? So on this problem, we are again dealing with population. The population here is going to be gallons consumed of whole milk. Now y equals 16.5 is our initial amount of gallons that was being consumed. Now I need to find how much that's changing by, and the key word here is that it's decreasing by 4.1%. So when I do 1, I'm going to subtract away from it my 4.1%, which is 0.041. This is a decay factor because it comes out less than 1. 0.959 is my decay factor. That's 4.1% below 100% is what that is. Now I'll raise that to the x power. Part A is done. I will make a mention here that x is the number of years since 1980. Now going on to part B, I'm going to go ahead and apply that to the year 2000. What I'm going to do is have 16.5 times 0.959 being raised by the 20th power, because that's 2000 take away 1980 is 20 years has passed. When I type that in my calculator, I get about 7.1 gallons per person per year. And that's my final answer. Let me know what questions you have. Thank you.